Hello everybody, today we are going to talk about dynamic allocation of memory. But first let's talk how it is done normally. Well, when you write something like that, int array, and I will create an array of 100 elements, right? So 100 multiplied by 4 is 400 bytes. It means that when I click build and run, our compiler is reserving until our program ends 400 bytes of memory just for our program. Okay? And this is reserved for us. It cannot be used by other programs. Okay. And it means also that we can't, by typical defining like that, reserve more memory. We can't reserve, for example, after that, after compiling, after clicking that thing, when our program is running, more memory. But situations like that might happen a lot of times. It might be like when. Hey, imagine a situation like that. Cout. How many numbers would you like to store in an array? So I'm asking our user, and I will take the amount he wants to store. For example, like that, to that variable, right? And now we probably would try to do something like that. What is very, very wrong thing. Sorry. Int amount. It's wrong thing. Very wrong. When I do something like that, for example, I want to have 500 of that guys here. It means that I'm trying to right now get the value or change the value from the place which is free, or maybe it's not free. Because normally, I told you, when we did it that way, this thing happened when? Before compiling. And reserving memory like that is easy. But by doing it that way, we are trying to reserve something what is outside of our program space. And then we need special operators that can do that. Because right now when I do, for example, like that, it will compile. I can even send it to the output later. It's okay, everything is working. But, as you can see, everything works. But this thing that I assigned here, that value, could be assigned to the place, to the variable that is used in another program. And then our program would crash. Okay? Because that type of defining variable is not injuring us, is not making us sure about that memory will be free, okay? Well, our computer memory looks like that, for example. The red guys are reserved guys. Are reserved space of memory, okay? The blue ones are not reserved. And now, might be like, when we need that amount here multiplied by 4, we need that space in memory in a row. They must be one next to another one. They must be next to each other, right? Because that's how an array is working. Like I told you, when I do something like that a of 0, I want really something like that, and I want a of 1. I need something like that, right? The array is really a pointer, right? The the identifier of array is a pointer. Okay. So we might be now like, so how to do that? Okay, so this thing is wrong, of course. I've just deleted this guys here. And how to do that? We have something what is called new. That thing is telling to our PC that we need a free space in our memory after compiling. Remember, after compiling, not before. Whoa, okay. So we need it, and we want to be sure that it is free. We are just telling it to our PC just by using that guy here. And after it, we also need to tell our PC how many bytes of that memory we need. We can say, for example, I want 4 bytes of that memory. Or I can say, hey, I want, for example, 8 bytes of memory, right? Okay, so right now I'm telling, hey, I need 4 bytes of memory. And let's see if it is really an address, that guy here. Let's see. Let's send it to the output. As you can, maybe let's comment guys here first, because it will just take our time. Let's build it. And as you can see, it's just an address. It's good. But look. Isn't it this address every time different? Oh, sorry, I just didn't run that guy. As you can see, every time the address is just different, because we are allocating it dynamically. Okay? And can I get a value from the place? Yes, of course, we can get a value, but this might be a random value, right? Well, this is a random value because we have just got a free space in memory that could be used before by another program. But now it's ours, only ours. It cannot be used by other programs. Okay? Great. But now, hey, we have an address here, and what? We can send to the output the value that is under the address, or we can set the address itself. But, okay, I can also change the value here, but that's all. I'm changing the value, but the value here is again a new address that was just here reserved, right? So we don't have an identifier that we could refer to. So now you might be like, hey, but this is an address. It's an address, so I can store addresses. I can store them in pointers like that. I can do just something like that, and hey, I can store an address here, and I will be happy. Okay, now I'm storing address in a pointer. So I can send to the output the value that is there. I can also change that value, for example, to 50. Great. Okay, and now I would like to tell you about something very important. When I do something like a local variable, so local variables, I'm reminding you, are being destroyed after meeting the curly closing bracket. That thing here is called static local space, something like that. We could do just something like that. If 50, then it's dead. That thing will work without even checking the condition here. So this variable after that curly bracket is not going to be anymore in our program, right? As you can see, our compiler is telling us that P is undeclared, because after the curly bracket we can't get anything from that pointer here. So it also means that we reserved here a memory, and this memory, like I told you, belongs only to who? To our program. To us, right? And because of that, it's not free anymore. It will be always belonging to us, okay? So we have to do something with that. We have to free that guy, that space. We have to release that space in memory. In order to do it, we can use a word delete, and then we have to give an address of a place where, that want to be released by us. So we want to release the place that is pointed by that pointer here. And now we are sure, we are happy that this memory is free and it can be used by other guys later. But remember that this delete here doesn't mean that I am deleting the pointer. It is just releasing that address here. So it means that I can send after it the pointer, for example like that, to the output, and as you can see every time that address is the same. The addresses are the same still because he's still pointing to that place. But this place is not belonging to us anymore. It's not belonging to us. Because it's not belonging to us, we shouldn't change that value there because it's wrong. So when I do something like that here, of course, yeah, it will happen. I will change the value. But right now I'm changing value of a place that I shouldn't change. So, oh, that's bad thing here. As you can see, it's random value after deleting, right? Again, it can be used by other programs. So when we delete the space, we should always also assign here null. Null is just the empty space in our memory, something like 0, okay? And now, when I do something like, for example, if p exists, so if p is not equal to null, then I can do, for example, things like that. I can do that then. Then everything is fine. But otherwise, please just don't do that things here. Okay? So, if I do it that way, everything will work fine. And it's okay. But I should do it that way when I delete the pointer. Okay? We should also know that after deleting, that pointer here can store another address of another variable. So for example, that guy here, let's assign another value here. I can do something like, hey, okay, now I want to store the address of variable here. And now I can build and run that program. As you can see, I changed that value here also. Look, I can send it to the output here. It's changed. It's okay, everything is working fine. Great. But remember that this operation here is not dynamically reserving of memory, so I don't need to delete that guy here again, right? I don't need to free that memory. I need to free only memory that is reserved dynamically. This is just typical association. Okay? Okay, now let's go back to our problem at the beginning of our program. So let's comment that guys here. And now let's do the program that we wanted to do at the beginning. So how many numbers would you like to store in an array? I would like to store, for example, 500 of elements. So int, and now I will store it in a pointer equals new int, and here I can also in the square bracket tell our PC how many times multiplied by the type I want to have bytes, right? So for example, I will type here 5, so 5 multiplied by 4 means 20, so I want 20 bytes in memory. And the new here operator will return the beginning of that space that was just here reserved. So it will return the address. P will store the address. We can send it to the output, so we can see that. So for example 5, as you can see, here we have an address that is stored. As you can see, that the addresses are different, right? They are different every time. Okay. So let's also remember about that I have to delete the space that's reserved by that pointer at the end of the program. Remember always about that. And now we can do, for example, for int I, when I is lower than amount, I plus plus. And let's send to the output cout. Enter the, and let's send to the output which guy, so I plus 1 because here is 0, so 1, 0 plus 1 is 1, and number, and then colon, end line, and let's take that guy here. Because, you know, we can use that thing here easy, because as I told you, the point, when I did something like that, for example, array is really a pointer, right? So array plus 1 is the same like array of 1. And here I have just a pointer to the first element of address. So everything is working fine. And then I can send to the output that values that we just typed here. So I can just send to the output the P of I equals P of I. Now let's compile it. And I will type, for example, 5 numbers, 10, 40, 50, 500. And as you can see, everything is working fine. Great. Okay. But what will happen when I do something like that? I want to reserve that much of memory. This application has requested the runtime terminated in an unusual way. And because, well, we can't get so much memory, right? So we could here try to catch that error, but we'll talk about catching errors in other lessons. We can do something like that. No throw, so it means that we are not going to catch anything because we don't know how to do that. And if we don't have enough space, here to that pointer will be assigned a null. So we can do something like if p is not equal to null, then please just do the things here, right? But otherwise, say to our user that we don't have enough memory. So I will now do something like that, and as you can see, our program is at least working properly. So we could do after it other instructions, right? Okay. And now I'd like to tell you something very interesting. Let's comment that, guys, here. As a training. Let's go back to that code here and look. look at that thing. Oh, let's just comment it, guys, here. Okay. Let's do something like that. We are now reserving that 4 bytes, right? And we are sending to the output the just our address that's been just reserved. And we can see it's like, for example, 68 at the end, right? And what if I do something like that? Delete, then P, and I will do something like that, and then again that. As you can see, both times we reserve the same space in memory, because our program remembered that we can store in that place 4 bytes. If I did something like that, it would be a bit different, as you can see from that guy here. But look, now it's the same, but when I don't delete that guy here, as you can see, they are different. Why they are different? Because this thing that was reserved for our program, only for our program, is not free. We haven't released that guy. So we can't take that space in memory anymore. I'm just telling you that so you notice that we have to remember about that damn releasing of memory. At the beginning it might be for you a bit confusing why to do it. Really, it can make so many errors. Remember about it. It may kill your program. It might bug you, which means you have many errors. Okay, that's all in that lesson. Thank you very much.